to Chapter 4, Simplified Techniques for Diagnosis of the Soil Physical Quality. Today, we will provide you with the really simple techniques for you guys to analyze the soil physical quality. Remember, we have the selected soil physical quality. The first one is the maximum soil depth to root limiting layers. And the second one is the soil porosity. If you guys ready, come closer and take a look at each of them. The root limiting layer is the depth of soil that plant roots can potentially exploit before reaching a barrier to root growth, and it indicates the ability of the soil to provide a suitable rooting medium for plants. A soil limiting layer can decrease the available water holding capacity as well as its macro and micronutrients. Besides the hard pan, which really dense layers that block the flow of the air and water vertically, we have also the cause of the root limiting layers that occur by soil pH, aluminum toxicity, salinity, sodicity, and a high water table, and so on. The maximum soil depth to root limiting layer is really important. Here, I'd like to show you all with the example that you commonly see in your daily life. Basically, the root restriction. Like in this case, we have the plant that grows in a pot right here. So it's really common that you see the root restriction in here. So let me pull it out. Okay, here you go. See that? You have the number of the roots just a lot compared to the potting mix you have. So here is an example that the root grow into the soil is really important. This case we did on purpose because you like to keep this plant stunning. You don't want to have them grow like really fast, right? Now in the field, to check your soil maximum to the root limiting layers, you have to dig the soil from the top of the soil surface down into the soil. Now you have to check if those layer is thick enough for plant to grow. Let's say you didn't see any the limitation due to the hard layers or some other layers that kind of restrict the root growth, you'll be okay. You can check that and compare with the crop that you have. Let's say if you have the crop rooting system somewhere between 15 to 20, and in the field you couldn't find any the root restriction at all within like 50 centimeters, you will be totally fine with that physical quality. Soil porosity, if you remember in the previous chapter, we talked about the soil components in the water and air, which part is the porosity of the soil themselves. Now let's get started a little bit further. Soil porosity and particularly macro porosity influence the movement of the air and water in the soil. Soils with good structure have a high porosity between and within aggregates, but soils with poor structure may not have macropores and cause micropores within the large clots, restricting their drainage and aeration. Poor soil porosity causes not only lead, carbon dioxide, methane, and sulfide gases, but also reduce plant nutrient availability. Guys, I have a little experiment here just to show you with the case of soil porosity. We have two soil samples here with different porosity. I don't let you know yet which one has higher porosity, okay? But we have soil number 1 here and number 2 here. Alright, we have soils and water. I add just some food color just to make sure that you all can see the water level a lot easier. Now, what I'm gonna do here is let me give you some theory, but really simple. Soil porosity means that the pore space in the soil system. Normally, with this space, only air and water will occupy the same space, right? We have dry soil samples now. We have air in that pore space. Now we're going to replace that space with water here. So the soil basically that has higher porosity will hold a lot more water. That's it. Really easy, simple, right? Now I'm going to start with number 1 first. So what I'm going to do now is just lift the container here just a little bit, and I will turn around just to make sure that I can add water slowly and really smoothly. The reason that I have to do it really slow because I don't want to destroy the soil structure, because not just the structure that gets destroyed but also the pore. I gotta do it bit by bit. Once the water absorbed by soil, the soil color change to darker, right? So you can check that on your eyes that the soil already absorbed water. Okay, done. Just wait a little bit because you have to let the water move. Otherwise you add too much water. You can play this with your kids as well. It's really fun to check which soil has higher porosity. Let me move a little bit over here because the soil is still dry. Okay, I got one more spot over here. Okay, I'm gonna pour it really slow this time. I think okay, there you go. I think that's it. Okay, so I'd like you to see that all those soil aggregates now are wet. That's it. But you still keep the soil structure. That's good. Okay, I'll put it here. All right, and the water that we use is 40. We start with 100, right? Now I have 60 left. So the total that we use to that soil is 40, all right? 40 milliliter. Now we move to the second one. I'm gonna do the same. This one so far so good because this is the second time that I'm doing. Okay, I gotta be careful. Slowly, okay. It seems like this soil can hold a lot of water. That's what I feel. I'm observing right now. And then, okay, we still have some spot left with the really dry. So I'm gonna add some more here. Few more drop. Okay, I have to wait this time. Okay, just wait a little bit because we have just a few aggregates that still dry now, but it start absorbing water. So just wait. Okay, I think I can add a little bit more. Just to dry. Okay. And just turn it around a little bit. Okay. I think that's it for the second one. So now let's check. Okay. All right, we start at 100. Now we have left just a little bit above 50. So let's say that the previous one we used water like 40 milliliter, right? But this one we used like almost 50. I would say like 48, something like that. All right. So 48 milliliter for number second and 40 for the first one. All right. So that means the second one hold a lot more water. In other words, supposed to be higher porosity. Now let's check it out, okay? Number one, we already do some calculation for the porosity, and the answer is 30, okay? Okay, let me put it like this. And the second one is 40. Okay, so this experiment is really simple that you can check the porosity, but in the field this is going to be too much, right? In the field it's going to be like something really simple for porosity. So I hope that you can see the figure tell you the difference between low, medium and high porosity. If you have no idea at all, let's think about the two cases, which really extreme case like high porosity and low porosity. Let me show you the example. Just come closer and then I will show you very soon. All right. guys, for the field measurement, you need something that really simple, right? So I have two soil samples here. One is all particles stuck to each other and the porosity is very low. This is the type of the soil where you can differentiate the difference between soil particles. So they all stuck together. So the porosity is very low here. And for the second soil sample here in my hand, the porosity is really high. You can see the pore just distributed throughout the soil aggregate. So this is the two examples that really different. In my hand, high porosity, and here is low porosity. Anything in between would be medium. So you can use this case when you be in the field in chapter 7. You can use this skill to separate the porosity in the soil system. Later on, you will figure out like how you're going to differentiate the soil porosity by your eyes in the field. Just make sure that you remember now in the case where you can see two cases very different. Here is high porosity and here is low porosity. Anything in between is medium. That's it. Alright guys, that is all for chapter 4. We meet it again very soon in chapter 5. You guys have a good day. Bye bye.